This was our first model, which was just a rectangular shape. We were just trying to do the most basic shape to begin with and how to improve from there. We compared our other models to this one in terms of buoyancy, which was tested by adding rocks and shoes, and resistance. This shape was not terrible, but we could feel the resistance when pushing it across the water. This model was 30 centimeters by 15 centimeters to represent our anticipated 3 meters by 1.5 meter big scale boat. Any modifications to this boat have to be within these dimensions.
Our second model was similar to the first one, except we made the front and back of the boat have a triangular shape. The reason we made both sides the same shape is due to the fact that we are not planning on turning our boat around during our race, so the front and back would have to be the same. We chose a triangular shape in hopes of decreasing resistance from the water due to its ability to break the surface tension more easily than a straight edge. We also predicted that the triangular shape would decrease air resistance as well, because the air would not be just hitting the flat rectangle and would be directed towards the sides instead. When pushing it back and forth, we did notice a significant decrease in resistance compared to the rectangular one. To test the stability and buoyancy of this model, we added different rocks in terms of size, shape, and weight. When putting the rocks on the boat, we noted the change in water level based on how much weight was on the boat. We also placed the rocks in different positions across the boat to see how the boat would react with different stress points on it. With this model, we noticed that the boat was not very strong and sank easily. When placing the rocks on different points on the boat, it quickly started to tip, showing that it was not very stable. We also added as many rocks as possible on the boat before it started to sink and have water get into it. We did this in order to see how much weight it could take before sinking, and we used this number of rocks in order to compare it with a different model that we had in mind in order to compare the buoyancy of the two models and to see which one worked best under weight in terms of strength and buoyancy.
Our third model was similar to the previous one, except the triangles were lifted at an angle to replicate the shape of a raft. We did this thinking that it would decrease the resistance of the water. When testing it, it did cut through the water more easily, but it compromised the stability and strength of the boat, because there is less surface area in contact with the water. When we put in the rocks to test the strength, it could not hold as many rocks as the previous model could. We did the same thing with the rocks on this boat. However, it could only hold 3 rocks before it started to sink versus 5 on the previous boat.
We compared our second and third models to each other by pushing them across the water next to each other. The second model did have a little bit more drag when pushing it across, but overall it was definitely more stable, and the difference in resistance was not that significant. The third model, although it cut across the water more easily, it wobbled a bit as it was moving across the water, showing that it was not very stable or balanced.
After testing all the models for a boat, we came to the conclusion that the rectangular base with triangular ends, the second model, is the shape we wanted to use. We noticed it was the strongest and most stable boat compared to our other models. Although it did have a little more resistance compared to the third model, it was only a slight difference. To us, the stability was more important than this small change in resistance. We cared more about making it as stable as possible instead of compromising the stability for speed. To make it stronger and increase stability, we decided to add cross sections to the base, which would add support when weight is put onto certain parts of the boat. When we added the rocks, the boat did not wobble as much as it did without the cross sections. It also didn't sink as deep as it did before. Because of our findings, the model boat will be the boat we will build and race with.
For a big scale model, we need to primarily focus on making sure that the points of the triangle are perfectly symmetrical and even, so the boat will go in a straight path rather than from side to side.